Nope.
Okay, so let's get started now.
Hello.
Yes, I'm here.
So you have you been through have you gone through anything regarding this actually structural modeling?
Yes, I have.
You are all, my voice is clear.
Yes.
Right. Okay. So I think maybe we need to focus on structure modeling this time, actually, right? Uh, I think that will be very helpful for solving our sample question as well. Shall we focus on the structure modeling? Last time we discussed about the data flow and the behavior modeling, right? We got some idea about how to go develop design system using those methods. But structure modeling, are you clear about? Have you seen any code using structure modeling?
Yes, I have.
So you have fair amount of ideas, isn't it?
Yeah, it's basically structural architecture. Use a lot of component. So basically, you need component declaration package with component, different port, right? Different port, and then combine them
Instead
together.
of instead of focusing on implementing functions, what we do in this method is little different. You completely cases in entity section, you completely explain about the design. Maybe wait, let me take an example so that you will understand it better. I'm going to explain you maybe some full addition. The internet is little slow. Perfect. So let's consider this circuit. Maybe uh, you cannot you cannot define its function in any terms. It is not a full adder or half adder or something. It is just a combinational circuit. You know what is combinational circuit?
Oh yes, combination of circuit. Yes.
What is it? Can you tell me the difference between combinational circuit and sequential circuit?
So basically, combinational circuit is consists of logic gates whose output at any time are determined from the only present combination of input, and then they have no memories.
Right. So uh, the other way is sequential circuit, right? Perfect.
Yeah,
So
yeah,
this what you start where you start from here is you actually see the circuit first and see how many AND gates and OR gate. There are two AND gates and one OR gate in this combination circuit, which means the AND gate is of same type, two input AND gate and one output, right? So I need to create entity for the AND gate and OR gate. I mean, uh, uh, if we want to solve the problem for the total combinational circuit, we need to start from the entity first. The
yep,
entity should not be defined for each component in the circuit. It should be it should be defined for the whole circuit. I mean, for the whole. How many input outputs are there, and you need to see from the higher level, like. Don't need to go deep into the deeper level, like how many inputs are there for each case. You don't need to see that. It is a complete circuit where I see that there are two AND gates and one OR gate, and there are four inputs to the circuits, right?
Yep.
I mean, two inputs to each gate, but four input to the circuit and only one output, right?
Yep.
Internally, you might have a lot of inputs that doesn't matter for the entity. Internally, you will have a output from the first AND gate, which is C, and output from the second AND gate, which is F, and they are acting as the inputs to the first OR gate. I mean, the only one.
So can we just
So that
can we not talk about this? Can we talk about something else? You know, can we talk about can we talk about I think I'll send you a PowerPoint. I will send you a PowerPoint. Can we do a little bit about latches, flip flop, register? I'm just a little bit confused about that. I think for this part I'm okay. You know, this
this
part
part
I'm
you're
okay.
okay, but are you okay with this actually? The entity stuff, this one, this part,
Then
are
the
you
the,
okay?
ent- the entity the entity is okay. It's just input and output, just define. You know, this is
Yeah,
actually
I
very
mean,
simple.
I want to talk about the component also. That's why I started from entity. If you see the entity, it completely represents the input and output stuff of this, right?
Yep.
After this, if you see the architecture where you you define each component of the circuit. Let's start from the architecture and underscore R underscore A of some of I entity. Actually, you are going to define architecture for the circuit. Inside that, you'll define each component for the circuit. If you see the component ports, um, first, what you do now, you do a you define the input-output interface for the AND gate. I mean, you just need to do it for only one AND gate, even though you see two AND gate in the circuit. Just by defining one AND gate, you can get instant of this AND gate in another variable also. So that's what you do here in the component.
Yeah,
You don't
absolutely.
need to define, right? You don't need to define two component for two AND gates. So you do that here in the first component and two actually, right? ABC. ABC are actually okay. It's fine. You understand that. What about the second component, R input, R gate, right? Which
It's a
is
it's a it's a
also
it's a it's a
declared,
it's a
which
it's a it's a it's the same, you know, you just declaration, you put that
no,
into
it is
this
the
and that.
same. But what you see here is also ABC, right? Can you see that?
Yeah,
Port
yep,
ABC. What is that? I mean, what they are trying to say here. But in case of OR gate, you see C and F to the inputs of OR gate, right?
yep,
Hello?
yep, yep. I
But
can
what
hear
you
it.
see here in the component stuff is A, B, and C is output, which
Yep,
means you are not mapping the real circuit now. You are just defining how the OR gate will be. It will have two inputs and one output. So that variables doesn't matter. The name of the variable doesn't matter. Where it matters is inside the begin statement. So after defining the component, you need to see the internal that is internal wires where the gates are connected. C and F are the internal wires. So that should be declared or maybe, yeah, that should be defined in the form of signal. Signal C is a logic, signal F is a logic. After that, you come to the begin. And in the begin section, what you're trying to do now, you have declared the complete object definition for the AND gate. But now you are going to instant. You're going to create or generate an instant for the AND gate using U1 colon AND 2, right? Which means what it does actually, you are going to create AND gate instant and you store the instant of that in the variable called U1. Maybe you can take it in any way you want. U1 will contain one instant of the AND gate, right? The begin statement. You see that? Yes, as or no? So after this, whatever you have done previously with the help of architecture stuff, component stuff, you're trying to map it. This is where you are really going to map the real variable that you see in the circuit with the normal general definition of the variable actually. See here, port map, then A equal to A, B equal to B, C equal to C. That doesn't change because the variable here is also in the same name, A, B, C for the AND one gate, right? The top one.
yep,
And you are defining top, I mean the first gate actually, first AND gate. And you are storing the instant of that in U1. And now you want to create another AND gate of the same type. And this time your A variable should be D. B variable should be E, C variable should be F. A, B, C are input, C is output. If you map that to the real variable, it is D and E input and F is output. And see the diagram here. D and E are input, F is output for the second AND gate. And you store the instant of the second AND gate in U2 variable, right? Hello? So
Yes,
you
I'm
just
sure. Yes.
created one, yeah, you just created one AND gate structure, but you can create multiple instances for that. And the next thing is the final one is you create instant for the OR gate. So when you try to map this real variable to the variable that you use for the definition of the gate, finally when you execute the code, this is how the code works actually. See here, port map AC, I mean the variable A, I mean the real variable, the real input for OR gate is C. The real input for OR gate is C, right? And the other input is coming from the second AND gate, which is F. So C, the F for input to the OR gate, and G is the output of the OR gate, not only for the OR gate, but for the complete combinational circuit. And that's what you see here. C should be mapped to A, F should be mapped to B, and G is the final output, is mapped to C, right? Hello?
Yep. Yep.
Understand this? So if you do this, what happens? When you execute this circuit, based on the input value, your variables will be mapped at this section, begin. I mean, the begin section. You have already defined the components in the architecture stuff, and the entity is representing the complete I/O interfaces of the circuit, the combinational circuit. Now you just need to map the port or maybe the variable using begin statement. That's it. When you run the begin statement, automatically the signal will go through the respective wires and it knows where it goes because you already mapped it using port map function, right? You
Yep.
understand
Yep.
this? Yes.
Yep.
Now, what I want to do is I want you to do is maybe see this is a little easy stuff, but do you think can you do this for off adder? Can you do this? Or maybe a full adder? Not
You
a
can
half
do
adder, a
that. You
full
you
adder.
you 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 can do that.
Right. Can do this. You want to do this, or shall we? Maybe see after this, surely we'll be discussing a lot about want to move one step at a time. How actually think? Can you hear me?
I can hear you. Yes, it's very
Hello?
loud and clear.
Right. Let's start with this actually a small maybe off adder is easy, right? Maybe we can do full adder. I just want to see the circle, full adder circle. This is going to take a lot of time. Let me start from this. The full adder, I know that it should start from this actually. Being I'm not going to design a full adder, just thinking how to design. Should I use to off adder for this, or maybe should I go with gate level? Let me check. So full adder, see this one. Yeah, we got this one. So this is full adder, right? This
Yep.
diagram. So we will try to do this. Mm, Now, how many inputs are there? Yeah,
So A, B, C in.
that's it.
Yep.
Right.
Yep.
Then sum is also there.
We also need out, I believe.
I think, yes. So I think this is out.
Yeah.
This is, now entity is defined, right?
Yep.
So what about next architecture? Right? And here is let me take so the architecture maybe you can give any name you want. So I'll go with this full layers full architecture, and this name should be the name of the entity, right?
Yep.
Right. Next is the component. I mean, how many AND gates I need actually. Let's start from AND gate, maybe XOR gate. Let's start from XOR gate. So XOR to inputs are A, B, C, right? XOR to inputs are A, B, and C is out. That's obvious. And the next component that I want to do define is what? Maybe add.
So
So
obviously
and
component
and
and
to
two,
and the
yes.
same. See, I'm not going to change the name of this actually because the structure is different and the gate component is different. And what I'm going to do, I'm going to generate or create instance for the each component. So I may use or I can use the same variable, which is not going to make any difference in simulation or whatever, right? Next is my orbit, right? Understand so far? No?
Yep. Yep.
So far, perfect, right? So now I want to see the sentence. And now maybe let's need to use signals also. There are so many internal signals, right? So we
Yep.
need to concentrate on that also. Let's define it. Tell me. First, maybe I think we should name it.
Oh yeah, absolutely. We should maybe
Maybe
EFG, different
what?
wires, different signal. Yes.
I
Hello.
take this. Are you there?
Yeah, yeah,
What
I'm
happened?
here. I'm here. I'm here.
Right. So this is the circuit, right?
Yes.
Now, maybe let me name it. This is my, what is that? Let's say C1 or not C. I don't want to use C or whatever. I mean uh, okay, let's say X1, okay, right? And what about this? This is my X2. This is my X3. Did I miss anything? No.
Not really, not really, not really.
No. So that's it. I think now this should be defined in the code, right? So my C is X1 and then X2, X3, right?
Yep.
And I think now I think we need to end our structure. Let's start our begin. This is where you need to initiate, right? Initiate each stuff. Let's see. I mean, let's start from XR. This also. Now begin. I want to start from XR. XR2, and I have initiated creating one in U1 actually, right? Created one in U1. Now, how will you map it? What is this actually? A, B, and the output is what? X1, right?
Yep.
In A and B are input. I use that, and output of the first XR get is X1. So this is should be like this, right? Yes. Understand this? No.
Yeah, I understand about this, sir. Absolutely.
Next is this. We use to, and I want to, I mean, do the same stuff again, right? I think I have forgot to. It is that. Now the next target, I want to instantiate the next target, which means the second target on the right side, the output side, which actually generates some. So in this case, my A should be X1. My B should be C in. And my output is S, right? Done.
Yep, yep. Absolutely.
And then the next stuff is this. And this is going to be my AND gate. AND gate being U3 and 2. And 2. And this time it is going to be what?
It's
The
gonna
first
be
AND gate, it is going to be what? X and
C.
C.
Yes.
X1 and C
Yep.
is already there. Then the output is X2.
Yep.
Right? Right. The same for the next.
We need B, you know, B and A.
What?
Yeah, B and A, isn't it? N2.
Now the second AND gate is going to be same. A is A. Right?
Yeah.
Hello?
Yeah,
And
I'm
the
still
B
here,
is
yeah.
B. B is B. And the output is X3. The final one is OR gate. Let's see the OR gate. So that's it, I think. OR gate should be like this. R2. This time it is going to be X2 and X3. X2, X3. And now I think this is X2, this is X3, and output is C, right?
Yep, yep.
And then the ends. Finally, you got to use the end, the architecture. And what about the architecture? What is the architecture name? I think it is full arc. Right? Done.
Yep.
So this is the complete code for the full ladder using in gate level implementation, right? But what full ladder circuit using off amp. Maybe you can do this. This is full ladder using off amp. This one. So now I want to see some internal signal representation. Yes, if this is possible.
So
Can you
can
see
we
this?
just can we not talk about this now? I think we had enough about this. I don't want to talk about it. Can we talk about latch and flip flops and register? Can we talk about all those kind of things? I honestly this part is okay.
Okay. So we want to discuss about latches and other stuff.
Yes, yes.
Let's do that. So okay, do we want to take any example? Like
I'll,
maybe we
I'll,
can do a kind of multiplex series combination. I mean, yeah, I think. I mean, you want to do the sequential circuit in structural modeling in or in general.
I think we can move past this. I think we can move past this. We just need to focusing on the register, and then we maybe do a little bit test bench and simulation. You know about those kind of things. I want to get this started, and you know, what do you think? I think this is how I think. You know, and how I want to go forward instead of we just focusing on the structure and behavior. This part I think I'm okay. You know, I'm quite comfortable with this part.
Hmm. You want to do a simulation stuff using
Uh,
some tool or something like that? Or
no. Maybe waveform. You get what I'm saying? It's like different kind of waveform. Maybe you can talk about that. So, have you received my mock test? Have you got my mock test?
okay, yeah. Where is it?
I think I sent you. I think I sent the guy the mock test. Did you receive WhatsApp or it's not?
Right, let me check it.
Yes.
Is this?
Yes. We can maybe do a part one. You know, we can do something like this. We can. I was thinking about we working on this. You know, but then it's okay. Maybe you want to download this or you want to.
This one, right? So
Yes.
complete architecture structure model.
Yes. Structural
Which
model.
uses two basic components, a flip-flop and the AND gate, right? The
T flip flop.
declaration of
Yes.
the components are given in the below. Label or relevant internal signal in the figure. Label all the relevant internal signal in the figure, right? So the code itself, code is given, I think.
Part of
Is
the
the
code is
code
given.
given?
The part of the code
Part
is
of the
given.
code is part of the code is given. So we should complete this code, right?
Yes. So we have to write the architecture. Entity is given. X clock. Q is output. There are multiple Q, obviously.
Okay,
But there's a
right.
four
Focus on
bits.
this.
Yes.
Wait. We need to start this. Start like this. So
Yep.
this is actually a register, right?
Yeah. Register. Yes.
I mean 4-bit register, and I think it does something else also. I think kind of circulation register, kind of what maybe you also try to implement register rotate operation. I think. So if you see that circuit gates connection and also the entity name register underscore SCIRC circular register circular, I think. So that's how the circuit works. You understand the circuit operation first. No, let's see. Let's define this first. So you actually see the circuit as a complete unit, and you need to explain. I mean, you need to see how many inputs are there. Only two inputs, right? Two inputs and four outputs. That's it.
Yep.
That's what you have done in the entity. Two inputs. You don't need to worry about the internal signals and other stuff. Yeah, to define entity. Port X and clock, and then Q is output. Q is of four different states, right? Q0, Q1, Q2, and that's why we see 3 down to 0, right? Q0, Q1, Q2. And then the architectural structure of bridge circle is. So what is this? What you're going to do here?
So I
I
assume
mean,
we
you need to do this actually. That's for sure. You are using D flip-flop. What is that flip-flop? T flip-flop.
T flip
It is
flop,
a
not
T
D flip
flip-flop.
flop.
So
Yep.
you need two component. One is AND gate, the other one is T flip-flop. Right?
Yep.
Let's see
Yep.
what component they have done here. Yeah, they have actually declared both the component. Component F of that is the flip flop is port EN is enabled and input T is also input, Q is output. Perfect.
Yep.
And then
Yep.
there is also another component and right
Yep.
and
Absolutely.
right. So that is also defined. But what they want is this one. They want us to use the process that is the begin statement. Whatever we have done here, we also need to define internal labels, signals, and other stuff. So we need to work on this actually. I mean, start from this, right? We need to
Yep.
work on this, and this, and the begin port map and everything should be done for this. So, but for doing this, I think we need to redraw the circle. So instead of that, what I do now, I'll take this circle. Now, you can name it in whatever label you want actually. So it
Sure.
is now up to you
I think
actually,
I think
right?
I think I think I think this should be I can label whatever I want, right? But you know but I need to make him understand. You get what I'm saying? Because if I don't make him understand, then you know we'll put a lot of trouble.
You understand this? No?
No. I know that I need to label a lot of signals and to make a lot of signals. Yes.
So then what we need to do actually? I mean, you want me to, can you do this or that? Maybe can you define internal signal and can you
No,
write these statements?
can we go through this together? That's my plan. Yeah.
Okay. Now you want me to do this or next
We
question?
we go through this together. You get what I'm saying?
So should I proceed?
Proceed. Yeah, proceed with this. Yes.
So now this now you tell me. I mean, let's talk about the first. I mean, maybe we can say like this actually. The first output of the flip-flop, right? Q0 is the name
Yep.
of the flip-flop, right? Maybe
Yep.
internally you want to name something else. That's good, right? Maybe we can do. Maybe this is the wire. This is the wire I'm talking about, right? I mean,
Yep.
the first input for the gate actually. It is already there actually, A and B. Let's do this actually. I mean, maybe here I think X1 is fine.
Yep. Yep. Absolutely.
And then here, I think the output of this is
X2.
given to the output of this, right? This one, right?
Yep.
Right? Perfect.
Yep.
So this is X2, right? So X2. And then X2 is given to the output of the second flip-flop is given to the input of the
Yep.
second
So
and
we
gate
make it
first input. So
X3,
that is
X4.
X3. X3. This is X4, right?
Yep.
Right. This is X. And then this is X5. Right? Yeah. Anything else? Any internal signal that we missed? Anything else?
So we missed a lot of things, you know. Wait. Let me think. Let me think. Let me see. Let me
I
see.
think we have missed it. We have missed. I think this is one. This is second. And I mean, I think this is. Wait, I understand. Sorry. X1 is fine. And next is output for this actually. Output for the first AND gate is missed actually. Right?
Yes.
So this is X2.
Yep. and there's x2,
and then out this is
wait,
also list. I mean output from the second input. This is the x3, right? Right. And then this is x4. This is what it is. And then this is x5. This is x4 and this is x5.
this is all the way to x7, yeah. X4, x5,
Yes,
x6,
x6,
x7.
I think up to x6.
No, x7. Wait, let me think.
Yeah. X6 and then what else? X6 then what?
Wait, let me think. Let me think. This is x1, x2.
Log is there.
Oh, okay.
X6.
Yes, x6 is correct. X4, x5. Let me think. Let me think. So you need to think. Let me think. X6. Yes, correct. You're right. So they try to trick you, but our test will not last for an hour. So this type of question they like to test you, They're not gonna ask you some very complicated things, but they want to, try to make it, a little bit complicated, but not too overtly complicated. You get what I'm saying? So hello?
So that's it, right?
Yeah.
They will ask you even more advanced questions.
Not really. Just focus on the practice question. Let's just focus on this. Okay, so
right.
Just
so
focus
now
on this.
Up to x6 is done, right? Now what we need to do now, we need to see how let's focus on this actually. We need to focus on the first fifth. Let's see the name of that actually. What about the name of the component? It is f of, yes, yeah, it
FFN,
is f
FFN.
of, so this is going to be f of underscore n. And now, so I want to underscore n, right?
Yep.
Right. So now this is what we need to do actually. F of underscore n is stored in U1. Now the inputs are, we already know that actually. Let me see the structure again. What is the input? En, T, and Q.
Yep.
Right? En, T, and Q. Here, T means clock.
Yep.
En is enable and Q. So which means En is mapped to X, right?
Yep.
No?
You're right. You're right. You're right. Absolutely.
Then what about T? T is mapped to clock. Yes.
T is clock. Yes. T is a clock. Yeah.
And then what? Next. Next is what? Clock is not going to change. Clock is always T. And then the output is what?
Output is X1. Q is X1.
No. Yes, I think the output is X. That's perfect, actually. Q is X1, right?
So sometimes I scare. Sometimes I make a mistake. I put X1 and then the things X1Q. The flip. Mirror the thing. Make a mistake. Because of this. Left, right. Sometimes get confused.
I think you see the direction, arrow mark direction. This will create, yeah. There is a direction, right? If you do it in other way, it will come to the left side. Now it is on the right side, which means En is your real variable. And En is your general variable, En, T, and Q. But the real variables are on the right side. You are assigning to that X clock and X1, right? They are all your real variable, right? No, yes?
Yes, yeah.
No? Yes.
Yeah. Sometimes I'm scared. Sometimes make stupid mistake.
Yeah,
Yeah.
I think we need to do this for 4 times actually, but we have to be very careful with this.
Yep.
I know this is not easy.
But so
Then we
this
have
one, should I just put U1 is FF0, FF0, FF1, and then
you cannot
FF2?
do that.
Why
You are
not?
what you are trying to do here is creating the component with the name of ff underscore the n. That is actually the real object.
Okay. So
You are
we do
trying
the
to get. Maybe you can do this. You can do this. This is fine. This is accepted. Hello.
oh yes, I'm here.
ff0 is normally a variable name. So this is accepted. Maybe
Okay.
you can do this.
Okay.
And then this is f1, right? According to you.
Yep.
So that's perfect. Now this is what we need to do. The second is en is equal to x2.
But then so this kind of things will make the QX2 change, right? They will make some changes, right? There must be some changes. There will be I believe EN is X2.
x2, yes,
And
there
then
is no doubt.
T is clock, yes. And
T
then
is clock, that will never change. Then q is different actually. Q
yeah, Q
should
is
be your
X3.
x3. That's it. Don't complicate. This is simple. Right?
Yep.
Hello?
Yep. I'm here. I'm following, sir. I'm following. I'm thinking as well, you know.
So now what about this f of 2, right?
Yes.
And this time it is en equal to x4. So you should name this. This is actually how you should do the question, right? I think the questions are okay. You can manage. And then q is your x5. And this is your third flip-flop. That is fourth flip-flop. Starts from 0. Now your en equal to your x6. And t is your clock. Q equal to x3. I mean, in this case, q equal to, you haven't assigned any stuff for that actually. Maybe let's make this as q3. I'm not learning any, right? Hello. Should have assigned. Maybe this should be something like this. Maybe
Oh yeah,
here the output.
Do we need to follow this? Maybe Q3, Q2, Q1. Is it something like that, or is we did this wrong? Oh,
I
we didn't
think
assign this.
this should be XR. So maybe
Oh, okay.
something like this, right? Perfect.
Oh, okay.
Now this will work, right? So now I think we have covered everything for the flip-flop, right? Hello.
Yes.
Now,
No. So let me
now,
process. Let me process. Yes. We did cover
no,
everything in
now,
flip-flop.
I think now we need to focus on AND gate, right? And underscore the AND. Okay.
Yep.
And underscore. This is your and underscore 0. This is your and underscore the AND. And the first input.
So do we put 1, 1, 2, 3? Since this is 1, 2, 3, right? So should we just put
Should be
1?
x1, A and C, right? A, B, and C. So this is your A.
So is
This
this
is your B.
n0? Can we put n1 instead of n0?
Yeah, N0.
N1. Can we put N1? Since the first one's 1, isn't it? N1, 2, 3. Yeah, we can just do that. And maybe we can do that. Yeah. I'm just
Then you want
checking.
to do the same for this. F1, 2, 3,
Yeah.
and I mean we should start from this 1.
No. For this is fine. This is fine. We don't need to change this because you see, there's four flip flops and then 3 AND gate. So it's 0, 1, 2, 3. So just follow his order. You know, you see his order is okay, isn't it?
Okay, right. Fine. Right. So now fine.
Let me see.
Now
Let me
I
see.
think A is your what? A is what? A is your x1.
Yeah. B is X. B is
B
X.
is
And
your
then
x.
C is the X2.
A is your x. And then x2. What about output? Output is sorry. Yeah, output is X4, right? No? Yes. Output is X4, right? Next is what?
X
Three.
and 3, yes. So it's X4 and X5. X5, A is
X.
X5, and then B is X4, and then C is X6.
And then end architecture. That's it, right?
Yep.
Right. So I think this is fine. I think maybe you can give a try now. And we will try,
Hello.
right?
Yes.
What about the
Do
next question?
do we need to
Yes,
do
yes,
something
go ahead.
else? Which is to label all the two
Break.
basic use. No, not break. So this is correct. So are we done? Wait, this is done. You sure this is done? Hello.
Yeah, what happened? What do you want
No,
to
so
do?
okay, so can we go back to the solution just now? You sure this is correct, huh? And then
Yes,
where is
I
it? So
think we
where's
started
this?
from here. Yeah, it is from here. It is from here. Yeah,
Can you move down a little bit? So
not
I just
this, not this. Yeah,
yeah, I understood about this. Yeah, move down. So it's a 8n support map. A equals to x1, B equals to x, and then C is equals to
sorry, wait. Yeah, now
C is
you see
x2.
in the big.
C is x2. Yes, and then we just probably copy. Okay, so 15 marks we can just get from this. Very good. Okay, so can we move to question 3 for this part?
Hello.
Yes, move to question 3.
What?
Can we move to question 3 of the
String three.
yes? I'd like to do question 3 first because question 2 is quite long. I don't want to. We can have a break after question 3. Question 2 is about simulation, about all those signals and stuff.
Yeah, that's
This is
not going to work. Draw the
so
circuit corresponding to the following VHDL circuit. VHDL code. You need to draw the circuit for this. Label all the relevant nodes in your circuit and clearly indicate the type of devices this VHDL use. Okay, think about this. We are talking about D flip-flop, right?
yep,
And there is T1 and T2, two inputs, right?
yep.
And D out is the output. So I'm not sure about what is T1 and T2, but there is D in. Maybe T1 and T2 from some other circuit. Let's see.
I think this is like a flip flop. Is it like flip flop? This kind of
It
be
is a flip-flop.
is it a latch or a flip flop? Let me think. Is it a latch? I scared. I
It,
suspect
it, it is actually a kind of yeah, you can call it as maybe there is no clock signal, right?
it is
So
no
it
clock
must be a
signal.
latch. It is a
Latch.
latch, right?
Ha, latch. Bloody latch.
So now how will you draw? How will you go about this actually? Do you have any idea?
We first use so you screenshot the code and then we do this together. Let's go. So there'll be signals, the port, multiple port. My lecturers told me that we maybe draw a big box first. So we start from top to bottom. So port. So basically we draw a circle, big regular rectangle box. And then there will input D in, T1, T2, and the output is D out.
Let me draw this first.
Okay.
Let me draw this first. So it is going to be, it is going to have something, but I'm sure it is going to have D flip-flop, right? So D
No, latch.
flip-flop,
Is it flip flop or latch?
yeah, latch. Sorry. So it is going to have a latch first, and right. I think it is going to have what? What is the input? D, right?
Yep.
D. right? And next is D out. Right?
Yep.
And we don't know where T1 and T2 are coming from. We will see, right? We cannot define that now. It doesn't have any clock or something. That's it. This is how we can draw this first actually. And there are so many internal signals.
Why there's no T1 T2, sir? Why is that?
I mean, we can have, there is T1 and T2, but we don't know where it is coming from. There is
Oh,
T1.
you don't know where it's coming from.
We'll see how they are trying to make this. This is T1 and this is T2, right? Hello?
Yeah. Yep. Yep.
Let's see how they ask us to design the circuit. And there are so many signals, internal signals, right? A, B, C, D, E, F, G, H, cell, right? And now your D out equal to H. I mean, what you're trying to do here is your what? You're moving H to D out, right? Hello?
Yes.
And then D is your not D in. D in. D is your not D in. I mean, these are all your internal signals actually. And C is your not DB, not B. F is your not E. So now let's focus on this actually. D out is your H. D out is your H. So this is your H. And I think it is going somewhere. I don't know where. This is your H, right? Hello. D
Yes.
out is your H. Right. And D is your not D in. D is also coming out from this, and this is your not D in. Your D in is that, and
So break it out. Break it out. Don't put this together. Separate this. You know, maybe for this part you separate and then you connect these two together. You get what I'm saying? It's like you have this and then you try to separate it out because I'm scared that maybe he asks you some function XOR gate or those kind of things. Separate it out and then we just connect. Yeah. Otherwise, very messy. Yeah. No, you don't have to copy this again. Yeah. You want to copy this? Oh, okay.
What do you want to do? What do you want to do?
No, my view is that we do this and NOT gate. We have to draw the NOT gate as well. You see, there's a NOT.
Yeah.
There's three
Not
different
D.
things. Okay, not the
I mean, you're going to take this input and not, and this is going to be a NOT gate. I mean, the output of, I mean, the input is this, right? Right. And this is your D. Do you understand what I say? Hello?
Yes, absolutely.
Right. You got this, right? What about C? C is not B. Where is B? No idea. We'll see. F is not E. Cell equal to G or X or H. G and X. What is G?
Wait a second. Go back to circuit.
Yes.
D.
C equal to not B.
Wait, did you make mistakes? Why D is D, not D? D assigned to.
What? Do you understand this? I'm a little confused.
D. Okay. Okay, done. We'll continue.
No, I'm not getting this.
So who me? This? I don't get. I don't. D not D. No, I don't get this term. So why D not D? So D assigned to not D. Is it or is
D is assigned to not D. D.
Okay. Why is that?
I mean, finally, it is going to make a circuit. They ask us to draw the circuit. That's it.
Yes.
It can be anything. The circuit can be in any form, right? So that's how they use this actually. But they do have a lot of if statement T equal to 1 or something like that. I'm not sure about this. I think I need to work on this. I don't think I can teach you this.
Oh, you cannot teach me this.
Yes. I think I need to take
why is that?
I don't know. Maybe I think I don't know. Maybe I need a refresher. Maybe I need a. I think I lost touch. I think I don't know. I forgot it.
The latches, all those things you forgot.
Maybe yeah. I need to check. Have you seen this? Actually, do you have a solution for this? No, right?
I do have solution for this, but I don't want to give it to you, you know.
No. Even I don't want to see it, but I'm just telling my position. I think this is not going to work. Maybe we can. Maybe I don't know. Maybe you see this. Let's see. I mean, let me try this after maybe today. Maybe let me see this refresh it. If works, then we'll continue. I think this is not going to work for me. I lost it. I think I studied it long back. I could not recollect the stuff. There are two
Okay.
processes, right? I totally forgot it.
Okay. Okay. No, it's okay. It's okay. It's okay.
Right?
And
Maybe I think we completed one now. I think let's end this actually.
no,
I think,
you want to end this now?
maybe so.
Hello? What is this?
Let me see the next one. So let's see if I can do anything about that.
How about question 2? Can you try to teach me a little bit about signal, about
Wait.
clock simulation?
Wait. I think my system, right? Something happened. System got angry. Right?
Hello?
Yeah. Hello, are you there?
Yeah. Can we do question 2? Maybe we can try question 2.
Yeah, wait. Still two. Where is it? Oh, yeah. This one, right?
Yes. So it's about signals right now. It's about, they have a different port, they have a logic, and then they have this, if clock is 1, and then that's then the D, Q0. And then, they want to assume that. So what they want to do is they want to give me the followers a complete timing diagram. Can you do this? Can we do this? I think it depends, right? It depends on the different process, different clock, different conditions. So it's probably an edge trigger or something.
No, the clock is fine.
You
If
can
I mean every all the clocks are working. Maybe
are you
clocks are working
confident?
in positive.
Are you confident about this, or you're not very confident about this?
No, I think this is taking a little deep. I think I'm not comfortable with this. Let's close this. I think maybe I'll try to find. Maybe I'll coordinate with him. I'll try to find my other guy actually. Maybe I'm sure he will be in touch. I'll try to coordinate with him and maybe try to assign him actually. I'll talk to him. Right? Hello.
Oh yeah, okay.
That will be fine. Give me a few hours and take your time. I'll talk to the coordinator and see what can we do about this. Maybe
Okay.
if
No, it's
you
okay.
have you guys, yeah.
Yeah.
Let me take some time.
Okay. No, it's okay.
You
It's
have
okay. It's okay.
exam on Tuesday, right?
Yes, I have a test on Tuesday. I just want, maybe you can guide this together because I just want to make sure that everything. Okay, then we stop here.
No. I
It's
don't want
just
to. Yeah.
yeah. We don't want to
Fine.
waste my time and then waste your time and then we
That
do
is also very important, right? Let me find some alternative for this.
Yeah. Thank
You
you.
can
Thank
also
you.
tell the coordinator.
Yeah.
Maybe I'll try from my side. Yeah.
Yeah.
Thank you.
Thank you.